In this nugget, you and I get to discuss the concepts about resource pools and how they can affect performance in a vSphere environment. In our previous video, we identified how we can, at a virtual machine level, configure the reservations, limits, and shares associated for memory and CPU with each individual virtual machine. In addition to those configurations, we can also configure CPU and memory reservations, limits, and shares on a logical entity called a resource pool. And we would begin in vCenter by creating one or more resource pools, if we wanted to use them, associated with our cluster. So in this example, we have Pool A and Pool B. And the resource pool has those settings for reservations, limits, and shares. So for example, Pool A, we could assign 1,000 shares. And Pool B, we could assign 2,000 shares. So within our data center, if we're working with a cluster, which could contain several ESXi hosts all contributing their resources to the cluster, then within that cluster, these two resource pools could be used to divvy up the resources in that cluster. And we could think of these two pools, Pool A and B, if we created them side by side, meaning they're both directly beneath the cluster, they are at the same level. And in high school, I was involved in wrestling. And what I learned in wrestling is that they don't have a guy who weighs 85 pounds, which was me, by the way, wrestle somebody who's 150 pounds. They have different weight classes. Well, in that same kind of light, pools at the same level, or devices or entities at the same level, and let's call this level 1, they compete with each other for resources. So at the cluster, let's say we have a single cluster that has all of our ESXi hosts. That cluster effectively has access to 100% of all the resources. And then these two pools at level 1 can go ahead and consume those existing resources. Reservations, whether it's CPU or memory, are guarantees regarding the availability of those resources for an entity that has a reservation. So each of these pools could be claiming or reserving certain amounts of CPU or memory. And we could also set limits as part of the attributes of Pool A and Pool B. And in our example here, we could also set up these shares. Shares only come into play when and if there is contention. So if there's plenty of CPU and plenty of memory to go around, nobody really cares about shares. It's when we have contention and limited resource when shares become important. So in this example, Pool A has been configured with 1,000 shares, and Pool B has been configured with 2,000 shares. If we look at this from the context of percentages, at level 1, Pool A would have roughly 33%, and Pool B would have roughly 66%. Because at level 1, there's a total of 3,000 shares, and Pool B has 2,000, Pool A has 1,000, and those are the respective percentages. And I did round a little bit. That'd be 33.3, and this would be 66.6. Now, one of the cool things about resource pools is that we can put VMs into those resource pools. So for example, if we put VM1 and VM2 inside of resource pool A and VM3 and VM4 into resource pool B, VM1 and VM2 also at the VM level, like we looked at in the previous video, they also have their own individual settings for things like reservations and limits and shares. And for this discussion, let's just focus on shares, CPU shares, which will come into play and be important if there's contention for CPU cycles. And let's say VM1 has a default of 1,000 and VM2 has 2,000. And let's say VM3 has been set to 1,000 and VM4 has been set to 2,000. Now my question is this: what percentage of allocation will these virtual machines get regarding CPU if there's contention based on their current shares? Now to figure this out, it's a lot like custom subnetting. And I realize that not everybody's going to be familiar with custom subnetting, so let me share with you the high-level concept. The high-level concept is we take a network address like 10.0.0.0/8, which represents an 8-bit mask on this network address. And then we chop it up into smaller chunks. And then from each of these /16 networks, we can also further subdivide those. And the process of doing variable length subnet masking, which is what this is taking the larger chunk and then breaking it down into smaller and smaller pieces. So the 10.2 subnetwork, for example, we could break that down .1.0/24. So the 10.1 and the 10.2 are both subsections of the 10 network, and the 10.2.1.0/24 is a subsection of the 10.2 network. Another analogy, which applies both to IP subnetting and to our pools here, is a pizza. So for example, if we have 100% of a pizza, we got the whole pizza. At the cluster level, with a single cluster inside of a data center, and all the ESXi hosts belonging to that cluster, that's our pizza. And in a contention situation, Pool A has 1,000 shares and Pool B has 2,000 shares. So this would be Pool B, and this would be Pool A. Now, still in a contention situation for CPU resources, VM1 and VM2, because they're in Pool A, are going to have to fight over this piece of the pie. You know, the pizza pie. Because there's 3,000 shares there and VM has 1, he's going to get about 1/3 of that. And VM2 is going to get about 2/3 of that. So this is VM1 and this is VM2. We have about 33% for VM1 and 66% roughly for VM2. But I want to make sure it's clear that this 33% is 33% of pool A, which is only this much of the pie right here. So if pool A only has 33% of the entire pie to begin with, 33% or a third of this 33% is around 11%. So that would mean that VM1 has 33% of pool A, but since pool A only has 33% of the whole, VM1's share count regarding the entire pie would be around 11%. And we could do the same calculation for VM2 and VM3 and VM4. And the thing to remember is that these devices in each of their respective pools are fighting with each other for the resources that are available as part of the pool that they're in. So we have the option of using pools or not using pools. Using folders is a great idea just for raw organization of resources. And if you use a folder, it's not going to throw in all the calculations involved with the reservations, limits, and shares that come as part of a resource pool. The other thing that's possible, and it's not really a good idea, but it's possible, is we could have pools within pools. Consider this. If we have a cluster, which by itself could be referred to as a root resource pool, because that's where all the resources are, and then we have pool A and pool B, and inside pool B we have pool 3 and pool 4, and inside of each of those pools we have virtual machines, and of course those virtual machines also have shares associated with them. Regarding shares for a virtual machine way down here, and identifying what it's really going to get if there is contention, in the case of CPU, that is a very tricky one to calculate. So I would strongly encourage you not to nest one pool inside of another pool. And in many environments, they don't use resource pools at all because of the ability to do reservations, limits, and shares on an individual VM by VM basis. So let's check our list here. We can have pools, no pools, or pools within pools. We're going to contend with other devices at the same levels. And I also want to add within our same pool. So VM1 and VM2 are going to compete for the resources available as part of the pool that they're in. And pool A and pool B, because they're at the same level, are going to compete with each other for the resources available in the parent pool. In this case, if they're in a cluster, that cluster could be referred to as the parent resource pool itself. Now, another nasty that can come up is, what if we have like 15 virtual machines in pool A, 15 virtual machines in pool B, and our plan is to continue to put virtual machines into one of those two pools? That is very workable. However, what if accidentally we create a VM right here in the cluster? We forget to put it into one of the other two pools. Well, by default, that machine, that virtual machine, is going to have 1,000 shares for CPU. So what happened to pool A and pool B regarding their shares? They're not worth as much as they were anymore. So because now we have 4,000 shares available and pool A has 1,000, he would now have 25%. Pool B would now have 50%. And this one virtual machine, happy day for him, he now has 25%. So the shares available for this VM are equal to the shares in the entire pool A. And the good news for this VM is that all those shares are his. Well, in the case of VM1 and VM2, they've got to fight for that 25% that's in pool A. If we set the option for expandable on this pool, expandable for this pool means it's okay to go ahead and ask the higher level parent. In this case, it would be the cluster for those additional resources. So if pool B and this VM are not using the additional resources that pool A would like to get, the cluster in this example, which is acting as a root resource pool, can go ahead and allocate those resources down to pool A. That's what expandable is all about as a property of a resource pool. If, on the other hand, pool A was not set as expandable and there were VMs that were asking for more resources, pool A, without that expandable option, would just say, no, sorry, I can't go ask mom or dad or grandpa. There's no more available for you. I'm sorry. And as part of not having enough resources, reservation admission control simply says this. If there's a virtual machine, we'll call it VM number 5, that's in this resource pool. If that virtual machine has a reservation that says, I'd like to guarantee so many gigahertz of CPU cycles, or I'd like to guarantee so much memory, and we try to bring that virtual machine up, if this resource pool does not have the resources, whether it's memory or CPU, that VM number 5 has been configured as a reservation for, it will not allow us to bring up that VM. And they refer to that as admission control. We're not going to bring up a virtual machine that has reservations associated with it that we cannot meet. Now, in the event that this pool was expandable, it could check with the parent, ask for those additional resources, and if they were available to meet the reservation of this virtual machine, those resources would be allocated through this pool, and that virtual machine would be able to come up. Now just realize this though. If we did borrow some resources and VM5 is up and running, VM5 is hanging on to those resources until it's powered off. Another thing that's important to be aware of regarding pools is that we can also set, for example, reservations and limits at the pool level. So what happens if Pool A and Pool B are both configured with 40 gigahertz CPU reservations at the pool level? And they've also both been set up for 20 gigabytes of memory as part of their reservation. And of course, for each of the pools, we can also specify the memory shares or CPU shares, which come into play with contention for those resources. Now, here's the unfortunate part of the story. What if we've set both these pools up, and we're putting all of our devices in Pool A, and we plan to later put some devices into Pool B? Well, because Pool B is there, and it has reservations for 40 gigahertz and 20 gigabytes of memory, all those resources allocated and reserved for Pool B are going to be withheld from the VMs that are currently running in Pool A. So it would be a mistake to create a pool, set up a whole bunch of reservations for it, and have those resources be unavailable to active running VMs in our environment. Now, just for fun, I created a spreadsheet. I got tired of doing the math calculations by hand, and so I created a spreadsheet that reflects Pool A, which is right here, Pool B, which is right here, and also the option of putting in a third device at the same level of Pool A and Pool B. So this could be yet another resource pool, or it could be a virtual machine. All the devices at that level are going to contend with each other in the event of scarcity of a resource, such as CPU. So in this example, currently I've got 4,000 shares in Pool A, 4,000 shares in Pool B. I don't have any shares associated with the third machine yet, so that machine is out of the picture. And VM1 and VM2 are both using the defaults of 1,000, and VM3 and 4 are also using the defaults of 1,000. And as a result, it's a beautiful even split. 25% of shares are associated with VMs 1, 2, 3, and 4. So in the event of CPU contention, which is what we're focusing on in this spreadsheet, each of these 4 VMs would be given an equal share of what's available as far as CPU. So if we change some of these, for example, let's say Pool A has 1,000, and let's say Pool B has 2,000, which makes it look like our drawing. Now VM1 and 2 are going to have approximately 16% of the entire enchilada regarding CPU shares. And VMs 3 and 4 are going to have about 33% each. And that's because VM1 and VM2 are fighting for the 33% that are associated with Pool A, and VM3 and 4 are fighting for the 66% which are associated with Pool B. So next, let's mix it up a little bit. Let's go ahead and give this virtual machine 1,000 shares, which is the default, and VM2 will give 2,000. And then VM3 will give 1,000, and then VM4 will give 2,000. So we'll plug in those numbers. So VM2, I'm simply going to click on that cell and put in 2,000. And VM4, I'm going to click on that cell and put in 2,000. So now as far as a percentage of the entire pie that's available, VM1 has 11% approximately, VM2 has 22%, VM3 has 22%, and VM4 has 44%. Next, let's add to the calculation another machine that could either be intentionally or accidentally put at the same level as Pool A and Pool B. And let's call this VM number 5. And we can show the calculations for that for this third device regarding its shares and press enter. It now has 25% of the available resources, and with the little magic of editing this Excel spreadsheet and the graph here, which reflects its shares of 1,000 getting 25% of all available CPU resources from the cluster. In this nugget, we've taken a look at how we can control shares, reservations, and limits at a container level using resource pools. In our next nugget, we'll take a look at implementing some resource pools. So I look forward to seeing you in that next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.